up next we have Zero Clients in the Enterprise, and we have Eldar here speaking. Did you say name right? Okay, cool, got it right. And so this talk's going to run from 2:30 to 3:30, and at 3:30 we've got a break, and then we'll be back at 4 with the Cert Australia talk, which is a substitute for the talk that was already there. Anyway, I'll hand over to you. Round of applause, please.
So, we're here today to talk about zero or thin clients and security. So we'll start with sort of a bit of a background, why do people use thin clients, what are they? Then we'll talk a bit more about the actual technical details that goes into the design and how they operate. We'll drop some root shells and reach some conclusions again in the end. Hopefully we'll have some room for questions, but we'll see how we run. All right, why do you care what I have to say? I've been a pen tester for almost 10 years, done security research for a bit longer than that. I'm one of the CREST assessors. Occasionally I do training at comms. You can find me on all the social media, usually as Wargool, and I have a very outdated blog, just another hacker.com. A lot of people here know who I am already. For people that aren't in security, I'm probably more well known for getting involved in this thread where Elon Musk and Notch was trolling the flat earthers. So, that's the way it goes. Alright, zero or thin clients. So does anyone remember mainframes and terminals?
Hey, I still work with them.
Right, so it's sort of everything that's old is eventually new again. Thin clients are essentially very small, low-powered devices that lets you remote into the cloud or some bigger computing resource where you do your actual work, you store your actual files. And part of the idea is that the thin clients are more secure because they don't actually handle the data directly, yada yada. So, who uses thin clients? You generally find it's large organizations where buying a low-powered device as opposed to an actual desktop can save significant money in both utilization as the amount of power it draws, but also the actual hardware capacity is often cheaper. They're often seen in deployments ranging from like 1,000 to 10, 20, 30,000 deployments. Typical silos where you see them are government, defense, industrial, military defense, contractors, large financial services. Basically anyone that's big enough to have a significant cost saving by deploying these things are likely to run them. We definitely know that the Australian government have had some of these in the past. Reselling these may not be as much of a problem, but if you are interested in sort of having a go at hacking one of these things, the stuff I'm presenting today is kind of scratching the surface. There's a lot more attack surface, a lot more software to look at. These are pretty cheap second-hand, $100. Pick one up, plug it into your network, go have a play with it. So, what is some of the known problems with these? Well, if you have a network of 10,000, 20,000 identically deployed machines, all it takes is a single vulnerability to bring it down. Right? This is all. We've known that ever since we've had heterogeneous networks. Software has flaws. That's also a pretty constant given. These things are often marketed as secure, and we're here to challenge that marketing view today. It's also presented usually in a secure as in this thin client in its own little environment is secure. So then you plug it into a network and start handling user data this way or that way, or USB sticks, and then suddenly that notion of security kind of falls out because you've gone outside the little bubble that marketing promotes it in. So, all right. So once you have one of these and you want to start doing some research, there are some sources of information. Obviously, past research is always a great starting point on everything. All good? Just the usual AD issues. So, past research is always a great starting point. there are a few things. I'll drop a couple of links later on. But you can always look at what people have done in the past and then build on that or do something different. Actually getting, well in this case I'm talking about HP thin clients, but actually getting a thin client and actually digging into it, using the documentation, access to public files or the files that are on the client itself, and start reverse engineering applications. It's usually a great spot, particularly because while the documentation might be a great source of, sorry, the projector is, so while the documentation might contain valuable information, it's always good to trust but verify, so consider reverse engineering the software. So, MCC Group published a white paper focusing on the WISE thin client a while back. They drew the conclusion that its security is pretty abysmal. And Roberto has done some stuff in the past on HP thin clients, similar to a lot of the work that I've done as well. And he's published these two blog posts on basically using physical access to pop a root shell in a couple of minutes. So, if you don't want to go and buy a device, you can create a virtual machine. That's where I've done most of my research. HP has the images online. Just hop on the FTP server, that's where you'll find files, updates, service packs, documentation, etc. So just grab that. It's a straight up DD disk image. You unzip it, or de-unzip it. Convert it to, in my case, VMware disk, create a new virtual machine. So I have an existing disk, and off you go. Alright, so once you start playing with it, you'll find that there's a couple of underlying design principles that determine how the thing behaves and what it works with. So there's two base OSs for HP in particular. There's the Windows Embedded and FinPro. I'll predominantly be talking about FinPro today, which is basically just Debian with some HP stuff involved. Alright. So it has a couple of operational modes. When you boot it up, it can operate as a thin client, which is kind of closer to a desktop. So usually the thin client just boots into its normal operation mode, and then you remotely connect to where you want to do your work, whether that be Citrix, remote desktop, VNC, has SSH support, a number of different ones, VMware View. Whereas the serial client, the kiosk mode, you tend to define a single connection, and it'll boot up into that connection, and if you close that connection, it'll reboot and boot back into the same connection. So it'll only operate in like one mode, which is pretty common for stuff like Ethernet machines at libraries or whatever. And then, of course, if you have admin creds, you can shut down all the management software and use it as a desktop PC, but you're going to kill the flash doing that. It's not recommended. You can, however, do it. So the biggest difference, like I said, is the types of configs. So you can see here, thin client, you have a lot of configuration options. The other thing is you can usually have multiple connections going at the same time. You can have one to Citrix, one to VMware, one to a browser, etc. Whereas the kiosk for Smart Zero mode, it only supports 4, and you can only have one active at the time. So, if you're managing this, you'd be glad to know that there are patches and updates available now and then. It's not super great. So the virtual image that I'm using is this one here, released just under a year ago. And since then, they have released exactly 0 package updates. That's good. They have released a couple of service packs, but as you can see, that's less than 1 a month, and they're mostly for like 3 or 4 different software packages on the box itself. So overall, it lacks things like kernel updates, and driver updates, and shockwave updates. So this is the latest version of HP thin client. It's running Flash 11.2 with public exploits. Luckily, it doesn't work on this particular architecture for some reason, but I didn't have time to really port the exploit to it. There are other ways to get shell. So once you know that you have a base OS and the management that they add on to it, like the difference between a thin client, a zero client, and the management software, because once you have a deployment of 10,000, 20,000 machines, you don't want somebody walking around with a USB stick updating them individually, right? That's not a great business model. So they have a couple of options for remote management. So direct remote management, you can log in through VNC or SSH in the case of the FinPros, IDP for Windows, and then they have, of course, their own complete management software that's able to both interact with the individual machines, but also do configuration, deployment, etc. It operates on two privilege modes. There's a user and an administrative privilege level. So obviously on Linux, that administrative privilege level is root, and then user is and it auto logs in, so you boot it up, it just gives you the HP thin client or whatever interface with your available connections with Citrix or Firefox, etc. Or you can turn that off. It's also possible to connect to Active Directory or Eldar, and I have done zero research on that, so if anyone wants to build on anything, that's a good starting point. I would not be surprised if you can just auth bypass and go right ahead. So on the actual box itself, processes again run as either of the privilege levels, and because of the way they've designed the software to be able to go from a normal user with administrative function to say reconfigure the network, etc. A lot of stuff run as root, but then when you do certain operations, it'll run sudo and then another command to lower the privilege that you can't sort of privilege. And there's this one file or a flag, var run httpc admin, and that's used to determine whether or not a piece of software behaves a certain way because it's a privileged operation, or the other way because it's a non-privileged. And of course, with this, you have to have 100% test coverage of all privilege escalation or de-escalation for every known operation and every known sequence which they don't have. And this is how most of the past privileged operations occur. And the old ones, you actually used to be able to go, please generate me a diagnostic file of this workstation, and it would just go, oh, here's the root password, here's the keys, here's my, just plug it up in the USB stick and walk out. So handy for red teams. Right, so we're going to do a demo where we elevate our privileges and we sort of highlight some of the things we talked about with the admin flags, etc. So there's no get system exploit for this device, but there is no shortage of privileges. So we're going to look at a local access one. So this is based on you having physical access to the device. So this is the latest version. It's running in kiosk mode, so the only thing we are allowed to run is the browser. Now, does anyone know a good way to get root on software? Oh, any workstations? No? Any ideas? You start with the printer, of course. So we're going to go into the printer here. And we don't really care about the printer, but we want to troubleshoot a non-existing printer. It's not listed, but it's a local printer, yes, thank you. Please troubleshoot my printer. Yeah, no, it didn't find my printer, that's okay. So it generates this diagnostics output. Okay, that's fine, I'm saying you don't actually have a printer. So what we want to do is we want to save this, and because this particular piece of software runs as root, we're able to just save this as the admin flag. Now, before I do that, I just want to prove that if I try to admin mode switch, it'll ask for my password, right? So I'm not currently admin, I'm not root. And the other thing that's interesting to see is in the available software that I have to choose from here is I've got one connection, and I've got a couple of pieces of software. And then what happens is once we save the admin flag, you'll see that, oh, look, we've got control panel. Because, you know, rather than logging out and logging back in as root, we just want the, you know, software to change behavior. And then what we're going to do is we're going to go to a known problem. So I told HP about this 3 years ago, roughly. And again, this is the latest version, so they took that very seriously. And as you can see here, we just had in the VPN config a command injection for Xterm. We do that, and then we're just going to wait a second. VPN connects. All right, thank you. So yeah, always make sure that your software runs with the appropriate privilege level. So, all right. And so one of the next design principles or problems that we might have to overcome is around the file system. So these things run with Flash, and it runs with the Flash write protected, because it wants to save protection. It has, in Windows it has a RAM disk, on Linux it actually has a partition on part of the Flash that is marked as /temp and /writable, and the write support here. However, if you root, you can just call this fslog, fsundoc commands, handy bash scripts included there, and then enable write access to the root partition or not. It also has this interesting side effect that because nothing can write to the disk, but temp is the designated write location with weak file permissions, all sorts of processes write stuff to temp all the time, and then you can just raise condition for root, even if they fixed all the other stuff. This is a design problem. Right, on Windows, similar kind of thing, but I think it installs itself as a driver. Like I haven't done a great deal of work on the Windows side. Create a RAM drive, and then you can actually define filters that allow certain files to pass through. And then once you reboot the device, all the existing writes to that RAM disk is removed. And of course, the admin user has the right to turn on or off. But unlike Windows, it requires, unlike Linux, turning it on or off requires a reboot. Now, there are a couple of cases, as you might see here in the red, where a normal user can disable the write protection, such as make the write protection reach a warning level of memory usage. So not even to the point where it's a problem. You just run the thing out of memory, and they go, oh, well, look, I'm running a bit low in memory, better raise a warning level, and that disables the write protection on next reboot. Because, sure, software requirements or something. Yeah. In addition to write protection, it also supports snapshots. So again, we're talking in the case of Linux here. The actual flash is mounted as .flash in the root. It comes with a factory snapshot already enabled. You can update that. You can change a different snapshot to become factory, etc. And you can manage it from the command line with HTTC snapper. Say if you did have access and you wanted to, persist, handy tool. And it's not like a disk image. It's just literally a copy of the root file system. So it's CP -R from root into this drive. So you'll see this. We have here flash snapshot factory root, and that's all the files from root copied in there. And there's a second directory that contains all the writable parts, so like the registry, the raw values, the config, connections, etc. Any files that the user is supposed to have, etc. Your Firefox skinning, if you wanted to do that. That would all live in this section. So, if you want to persist past the factory reset, you literally have two options. You can write your rootkit to the disk and then go HTTC snapper update the factory reset to the current one, which may, on a factory reset, someone might notice that things aren't factory default. The other thing is you can just call fs unblock and just write the rootkit into the // factory snapshot and then re-enable write access. Depending on which version of the thin client it is, you might have to try to run with the mark options and not just manually and of course, failing any of those, most of these models ship with a HP flash option and just actually update the BIOS. So you can always persist there as well. Right. A core piece of all the HP thin client software is Manticore. And Manticore is a framework that deals with registry values. It's literally registry for Linux. It has an XML file where everything's retained in. Sensitive data is encrypted with RC4. It can be exported and imported from the endpoint. And it's sort of the core component of all the management software. So it's used for distribution of configuration and deploying it. One other nifty feature is it can actually be used to deploy files. So if you wanted to have some sort of customization of the thin client, like the background image, for example, you can deploy that as part of Manticore. So this is literally what it looks like. It starts with a Manticore reg, defines a root namespace, and then starts to define, in this case, a profile, a set the resolution. It has literally all the values that any sort of config option for HP requires. It's all in there. And we can see here in the section that handles the VNC config, here we have an encrypted sensitive value. As opposed to just paragraphs. And in this case, is a file, HPEG profile. It sets the path as well as the file name. It seems a bit redundant to me, but sure, whatever. Sets permission, which is the UMask, sets the owner group, and then content is base64 encoded. There's also a function that supposedly lets you deploy a directory. I don't know what worked out what that is. It's some sort of binary structure. Right. And then of course locally on the machine there's a command line tool, mclight, which you can use to query the current values, update existing values. It will decode encrypted strings. If you run the VNC password was set, and you run that saying mclient get root VNC password, it'll give you the plaintext value as a non-privileged user. So there's that as well. If the root password has been deployed, it will give you the root password hash. Ask if you find it. So yeah. All right. As far as the encryption, if you don't have access to the mclient itself, you just have the actual content file that's being deployed. You can find that the encrypted strings are NLCR.1 mark. It's an RC4 cipher using a shared key. And the crypto people in the room will groan because you're not supposed to reuse the key for RC4. It's bad. So, yeah, they got shared key. I did a little bit of reverse engineering. While RC4 has that problem, you absolutely do not need to do crypto attacks on this kind of on this thing at all. All you need is strings. You'll see that the shared private key is literally the name of the software plus the algorithm plus the web key with some complexity. So you know. Well done. Right. So based on that, I wrote a quick tool that can just decrypt these string values. So if you ever come across the actual repository that hosts the config, based on that, yeah, you can extract the root password hash. PC passwords, VPN credentials, all the same things. So, which brings us to configuration management, which is how do you actually take the config and deploy it across a large body of bitcoins. They have a lot of tools that do exactly the same thing with minor variations. I'm not quite sure why you need this many solutions to solve the same problem from the same vendor. I mean, obviously some of them are for Windows and some of them are for Linux, but out of these ones, the only ones I've really done any work on are the bottom three. So the easy tools, the auto update, and HP device management. Now the easy tools are the oldest type of the bottom tools. They still exist on the latest version, but I've cut them down a bit. And one of the reasons for that is there's some non-flaws in the HP easy tools. And I think rather than solve those problems, they just went ahead and removed the functionality. So easy to deploy. It runs as a daemon on the device. It receives, it's a push solution from the server, pushes the deployment. So it just listens on port 4010. It has a web-like interface, so the server comes along and says, get whatever URL, here's the repository, etc., and then the client will then go, well, I'm being told to update based on the repository. It goes and fetches the config. It only supports FTP. Supports FTP, grabs down the file from there. So if you were doing pen testing and you see this sort of stuff, one of the nifty things is you can just create a listener and it sits on port 4010. And then whenever the next push comes along, you define a range of IP addresses and it'll just hit each IP on that port. That will give you the repository and any credentials that you need. If you're lucky, those credentials contain read-write access. It pulls out the config, modifies some values, deploy it again, and then we wait for the next day or next hour, whatever. The next push, and then your backdoor has been deployed. So. The only thing is, it has a tendency to do a DD update. If it thinks that you're trying to deploy an image, it will go, downloading the file, I'm going to run DD on my root file system, and then you bring the device. So be a little bit careful with it. So a couple of years ago, there was a guy who got 2 CVEs assigned for Easy Tools, and the blog post has actually disappeared. I've managed to find the reference from Google Cache, but it's actually expired from there as well, so I don't have a link for it anymore. But it basically says that you can man in the middle, or you can deploy a malicious image, which is fine. The other one is it has an admin password. You can set the root password for deployment through a URL as well, and it basically takes 3 values. It takes the current password, new password, repeat new password, and so you can just brute force. If you set all those 3 values to the same value, you say, hey, please change the password from admin to admin, and if it says, yeah, 200 okay, then you know the password is admin. I think you might have missed some of the other flaws. And the first one is, of course, this is plain text, right? So you can just sniff, or you can, like I said, you can create your own listener on the port, and just have the server try to push the config to you, and then you have all the details that you need. There's no validation, there's no signage, which you kind of get from the fact that you put the man in the middle of the image. The other thing is it's CSRFable, which is very handy when you're a malicious attacker. And again, because it's using anti-core, you can deploy arbitrary files like this. So we're going to run a demo. Same thing. We're going to deploy a config through CSRF. So you see here the iframe. We just, if you browse to a file that does an iframe to localhost, easy deploy settings. In this case, we're not deploying an image, we're just deploying settings. It's a really small little file. And in that setting, we're using the previous VPN command injection that we showed. got a demo for the local root shop. So we define here a gateway. That gateway is curl type sh echo. So that should run. So for this one, so we're going to use the older version that has the easy deploy. I'm going to fire up the browser. Reload this one. So this is just a plain HTML file that opens an iframe. So that iframe will force now the server will go FTP, it will download the settings file. That settings file, you can see down the bottom starting to spin. It's launching a VPN. The VPN will go curl, type that into sh, which then does wget on a zip file. That zip file contains a backdoor. And yeah, you got tricks there. One of the other things that it does is it actually contains sort of a wormable pot to spread across the network. So we'll get to that for the next section. So that's sort of the config deploy. The fleet management part itself, predominantly done through this one piece of software called HP Device Management, HPDM, and that is like a super enterprisey deployment thing. It has a bazillion different boards that does different things, and there's push and pull in different directions. And it's cross-platform. I've started working on reverse engineering some of the protocol, but I'm not quite there yet. So typically you would see this in sort of a satellite deployment where you have multiple segregated networks. You put a device management gateway on each one of those. You have a core server that does all of the operation. It gets files and images, etc. from the repositories, stores all the information in the database, and then you manage it from like these satellite consoles as the sysadmin. Yeah, exactly. Again, some of the things I've seen relate to sort of signature. Again, it's an XML-based Manticore at the basis of it, but it does seem to have some sort of MD5 signatures on the various requests. Doesn't mean you can't replay the request and make sure all the parts are being managed. The biggest problem I'm having at the moment is it's using compression, and until I reverse engineer the compression algorithm, doesn't seem to be any sort of normal stream cipher that I'm aware of. I can't man in the middle of it, so yeah, work in progress. If anyone has the skills to race ahead on that or want to collaborate, hit me up. Alright, so yeah, like I said, uses several different ports. There's like this whole sequence port used to identify whether or not a gateway is on your network, which one you should connect to, and then so a device, once it finds a gateway, will enroll with some sort of startup information, and it sends like things back and forth as these compressed XML blobs, which is largely a scheduled task that will execute a bunch of commands, or maybe write a script to the local host and run that script, both for extracting information and deploying information. So yeah, it's plain text, but it is compressed and doesn't need any checksum. So it's still though, because of the normal problem that all of these things have, does appear to have a bunch of rest conditions, and it runs this route. So it is a potential way to get Alright. The other one that's sort of enabled by default is auto update. So if you don't do anything, you're not running a managed operation, it just comes with this auto update. An auto update, you can either set it, say, hard code and config and deploy the config and say use this one server, check for updates every so often. If it doesn't have that, it defaults to DNS, so look for auto-update and you can run a responder or spoof or whatever and hijack it that way. You could technically even DNS cache poison that as an external attacker, which is interesting. The other one is DHCP tags, which I'm guessing a lot of organizations would be relying on. But if none of those things are configured, it defaults to broadcast, and then it will connect to a server running a web server running on port 18-87. And then on that one web server, you'll have existing config, clear device configs, it sort of falls back to sort of easy tools. Auto update is run from this one script here. As you can see, it gets the server info from the macro registry or something else. It will connect to the server, get a list of updates, check if any of those need to go in. Order and priority image, custom W packages, custom tables. Perfect. And then lastly, it'll apply the config based on that. So you can also run this as sudo. So as a non-privileged user, just sudo auto update malicious URL rootkit install as a service. So how do we get the broadcast to sort of point at our malicious server? So Wireshark, then we go through the steps of running an auto update. And you'll see that there's a broadcast packet being sent out on the broadcast IP that's configured. Use UDP port 18,286, and so we'll just drop the netcat listener in there. And you'll see that you'll get like this client string. But what does it expect in response? So we download the broadcast server or the EC tools, whatever it's called, smart tools from the FTP server. That's a .NET application, so you just drop into IOSpy. And the actual core loop of the application is just right here, and I know you can't read it. So this bit here, so the client will send client equals and a MAC address, and then it expects a return server URL plus string. That's fine. So I wrote a Python script, because I need to practice my Python, that sends a server URL back, ran through that. Sure enough, I was able to set the update server based on that. And because it takes a full URL as an argument, we don't have to run the web server on the 18,287 port. We can just run it on port 80. That's easier. But we want to do more than that. We don't just want to be on the same network as these people, and then you want to be able to do this as a malicious remote attacker, and then you want to be able to race the existing server that's sitting there broadcasting. So the way you do that is you have to get multiple people fighting to answer the broadcast, and whoever's closest get the fastest response. So we need a wormable broadcast hijacker. This is really sloppy code. So what it does is it grabs the IP address of the thin client that you're on, massages that into a URL, and then just runs in a loop a netcat listener that listens on the port and will respond with the server URL. So if you don't recognize the command line options for that one, it's the OpenBSD, the worst version of netcat. So it's not what you're used to from Kali. And again, because it doesn't have -K for photography use, I just put a really short timeout and put it in the loop. So it's possible it'll lose the odd race for the broadcast packet, but it does the job. So like I said, when we downloaded the tarball earlier and deployed our matrix screen, this one's included. So currently that virtual machine is sitting there spanning out, ready to respond to broadcast packets and hijack the update process. Right. So what we're going to do is we're going to do another demo. And it's pretty simple. So the table that we downloaded, it has the broadcast, it has a really skeleton repository screen, which is literally just a couple of directories called, image, custom, etc. In custom, there's a table called rootkit.tar.gz, which contains an install.sh file, and that's the core of the rootkit. And so, because it's hosting that locally with the Python simple HTTP server module, it's all sort of wormable. It can jump from machine to machine. Let's have a look at that. So as you can see, we're back to our friend one here. We have down here, we have, as you can see, it automatically auto-updates on boot. And at the time of boot, it even had a malicious things. You see here, it's looked for the DNS alias, and then tried to broadcast, and it didn't exist. So, however, now that we have a rootkit sitting on the local network, all we have to do is go start auto update, and the worm will spray. It's quite controlled. That's the other one. And then, of course, again, now this one. So now I have two sitting on the network. And, so yeah. All right. So, in conclusion, running a little bit ahead of time here. There are a lot of serious bugs in this platform. There's also a lot of less serious bugs. Some I've spoken about publicly in the past. There's a really good one on the old one where you can just reset the root password by running http security space -- unlock root. Yeah. But here's something that I was going to include a whole heap of different demos. This one I thought was pretty neat. Every snapshot script checks for this file /temp.factory reset, because no one beyond root is allowed to write into temp, right? And if that file exists, do not apply any resets, just exit. So it's pretty easy for the rootkit to avoid snapshots. Social engineer the passwords. Once you are remotely on there, you want to get the user's password, right? HP runs a lot of their custom software as shell scripts, and a lot of those wrap this custom HPTC dialog. So some people might remember dialog as like a script for window interface shell script tool. They have their own version that has some of these niftier features. But this is literally a shell script, so it'll tell you your password has expired, and this is a legitimate, it's not a fake. I couldn't fake that screen myself, but they've done it for me. Asks for the old password, asks for the new one, and then it spits it out and stands it up. So, as a remote attacker, you export X as 0, the X as 00, and then you run that command, the user will get an interactive pop-up, they'll enter the new password. You get the password and stand it out, and then you call a HTTP dialog saying setting password or updating password failed. Right. And then on the wiser. So yeah. All right. In summary, talking about thin clients, like they lack oversight. It's a closed ecosystem. You can't go in and set logging options. You can't go in and check what is on the file system. It has a really bad time to patch latency. As evidenced by the Flash version, for example. It has all the software flaws that any other software would have. There are buffer overflows in these things. There are logic flaws. There are injection flaws. There are CWE top 200 are probably all present. So, right. And if you are running these, network segregation is hugely important. You do not want these things sitting on any other network for the same thing. What about the malicious insider? Are we only secure if we're defending against people that shouldn't legitimately have access to this? So if I have legitimate access to one of these clients now, then you should attack another client. And of course, the elephant in the room is the fact that while these are separate devices that don't have access to your email directly, don't have access to your Word documents directly, they have Citrix or VPN or browser access, and they have DMC access on the device itself, so they can be controlled remotely. You can install a keylogger. It is effectively the same thing as having access to the company's website. It's just that you get to put secure in front of it or something. Yeah, that's it. Thank you for your time. Any questions?